Properties of multiplication of integers, NCERT Class 7, Chapter 1, page 10, Exercise 1.2. Integers are closed under multiplication. The product minus 5 into minus 6 is equal to 30. 30 is an integer. Product of minus 8 into 9 is equal to minus 72. Minus 72 is also an integer. So we see here that the product of two integers is always an integer. And generally we can say for all integers a and b, a into b is an integer. Multiplication is commutative for integers. Let's observe minus 2 into 8. Negative integer into positive integer gives me negative 16. Now I interchange the integers. 8 comes first and minus 2 later. 8 into minus 2 gives me minus 16. The two products are the same. Minus 9 into minus 6 gives me 54 and minus 6 into minus 9 also gives me 54. The two products are the same. So for any two integers a and b, we say a into b is equal to b into a. Associative property for multiplication. The product of three integers does not depend upon the grouping of integers. Consider three integers minus 5, minus 3 and minus 4. In the first case, we group minus 3 and minus 4 together. Now when I evaluate minus 3 into minus 4, I get plus 12 and minus 5 I write as it is. Now a positive integer multiplied by a negative integer gives me minus 60. Now let me take the second case in which I have grouped together minus 4 and minus 5. Evaluating the parentheses first, I have minus 3 into minus 4 into minus 5 is plus 20. Now minus 3 into 20 gives me minus 60. So I find that the first case and the second case are giving me the same product. So for any three integers a, b and c, a into b into c is equal to a into b into c. Distributive property of multiplication over addition. Now I have a left-hand term and a right-hand term. Now left-hand term is minus 7 into within parentheses minus 3 plus minus 5. So I evaluated the parentheses first. I get minus 7 into minus 3 plus minus 5 is minus 8. And now product of two negative integers gives me plus 56. Now let's evaluate the right-hand term. It is minus 7 into minus 3 within parentheses. So minus 7 into minus 3 gives me plus 21 plus minus 7 into minus 5 gives me plus 35. Now 21 plus 35 is equal to 56. Left hand term is equal to right hand term. So for any three integers we say a, b and c, a into b plus c is equal to a into b plus a into c. Let's take another example. Minus 2 into 4 minus minus 6 is the left hand term. Now right hand term is minus 2 into 4 minus minus 2 into minus 6 by opening the brackets. Now let's evaluate left hand term. We first evaluate the parentheses. So I have minus 2 into 4 plus 6 is equal to minus 2 into 10 is equal to minus 20. The right hand term, the first parenthesis minus 2 into 4, so I get minus 8. And the second parenthesis is minus 2 into minus 6, I get 12. So minus 8 minus 12 is equal to negative 20. Now the left hand term is equal to the right hand term. So I say for any three integers a, b and c, a into b minus c is equal to a into b minus a into c. Now multiplication by 0. the pattern given in the video for multiplication of two negative integers and using commutative law, we get minus 2 into 0 is equal to 0 and 0 into minus 3 is equal to 0. So for any integer a, we say a into 0 is equal to 0 into a is equal to 0. Now multiplicative identity for any integer is the integer which when multiplied by the integer gives the same integer. Now minus 3 into 1 is equal to minus 3. 1 into 5 is equal to 5. So 1 is the multiplicative identity for integers. For any integer a, we have a into 1 is equal to 1 into a is equal to a. Let's now multiply an integer with minus 1. If we multiply an integer with minus 1, we get its opposite integer. So minus 1 is not the multiplicative identity. Minus 3 into minus 1 is equal to plus 3. Minus 1 into 5 is equal to minus 5. So for any integer a, we have a into minus 1 is equal to minus 1 into a is equal to minus a. Let's find the product using suitable properties. Now 25 into negative 37 plus minus 37 into 75. I use commutative property and interchange the places of 25 and minus 37. Now minus 37 I take common from both and I have within parentheses 25 plus 75. So I have got this in the form of distributive property of multiplication over addition. Now minus 37 into 100 because 25 plus 75 is 100. So this gives me minus 3700. Now 4 into 32 into minus 25. I use the commutative property to make 4 and 25 together because it's easier for me to multiply. 32 into 4 into minus 25. So I've now used the associative property for multiplication and 32 into minus 100 because 4 is positive and minus 25 is negative. Product will be negative. Now 32 into minus 100, a positive integer multiplied by a negative integer gives me minus 3200. Minus 21 into 104. I split 104 as 100 plus 4. So this comes as distributive property of multiplication over addition. Now I can open the brackets. Minus 21 into 100 plus minus 21 into 4. Evaluating, I have minus 2100 plus negative 84. Now both the integers are negative. When I add, I get minus 2184. 125 into minus 45 plus 125 into minus 55. So I take 125 common and within parentheses I have minus 45 and plus minus 55. This is distributive property of multiplication over addition. So is equal to 125 into minus 100. And when I evaluate this, I get minus 12,500. Now 8 into 40 minus 1. I open the brackets. 8 into 40 minus 8 into 1. This is of the form A into B minus C is equal to AB minus AC. So 320 minus 8 and this comes out to be 312. Minus 15 into minus 49. Now minus 49 I will split as B minus C. Minus 15 into minus 49 I write as minus 50 plus 1. A negative integer plus a positive integer. So minus 15 into minus 50 plus minus 15 into 1. This I get by opening the brackets. Now 750 plus negative 15 gives me 750 minus 15, which comes out to be 735. And I've used the property A into B minus C is equal to AB minus AC. Now let me do minus 37 into minus 29 plus 37. In both these cases, I can take minus 37 as common only if I write 37 as a product of negative 37 and minus 1. So I do minus 37 into minus 29, and in place of 37, I am writing minus 37 into minus 1. Now I take out minus 27 common and I have minus 29 plus minus 1. Now minus 37 into minus 30. This comes out to be equal to 1110. Now for any integer a, what is minus 1 into a equal to? Minus 1 into a is equal to negative a. Now determine the integer whose product with minus 1 is minus 22. Now if I multiply an integer by minus 1, I get its opposite. So 22 is the integer whose product with minus 1 will give me minus 22. Now in the second case, B case, minus 37 is the integer whose product with minus 1 will give me 37. And in the third case, I multiply 0 by minus 1 and I get 0. Let's verify the following. I have the left hand side equal to 10 into 8 plus negative 6. A positive integer added to a negative integer. So we subtract. Answer will have the sign of the bigger integer. So I write plus 2. 10 into 2 is equal to 20. Right hand side is 10 into 8 plus 10 into minus 6. Now 10 into 8 is 80 and 10 into minus 6 is minus 60. And 80 plus minus 60 will give me 20 because I am adding a positive integer and a negative integer. So I have to take the difference and the answer will have the sign of the integer which has bigger absolute value. Now left hand side is equal to the right hand side. So here we have proved the distributive law. Now let's take minus 21 into minus 4 plus minus 6. This is the left hand side. Minus 21 into minus 4 plus minus 6 can be written as minus 10 because I am adding two negative integers and the answer will have a negative sign. So 21 minus 21 and minus 10 will be equal to plus 200. The product of two negative integers is positive. Now the right hand side. Minus 21 into minus 4. Product of two negative integers will be positive and I write plus 84. Now product of two negative integers minus 21 into minus 6 is plus 126. So 84 plus 126 gives me 210. So left hand side is equal to right hand side. So here also I proved the distributive law. Now starting from minus 1 into 5, we write various products using some pattern to show minus 1 into minus 1 is equal to plus 1. We've already done this when we studied the multiplication of two negative integers. So we are writing the same pattern and we'll find that in the end we are multiplying two negative integers. So when we multiply two negative integers, I will get 1 and 1 can be written as 0 plus 1. So seeing this pattern, we have written down the various products.